Welcome to Technically Speaking, where we help you increase your income through tech.
Introduction to Networking, How Computers Communicate, Week 2. Welcome to Week 2 of your tech journey. By the end of this lesson, you'll understand what computer networking is and why it's important, the different types of networks, LAN, WAN, internet, etc., how devices communicate using IP addresses and protocols, hands-on activity, which will be setting up a basic home or office network. So let's start our lesson with what is a network and why does it matter? Now, by definition, a computer network is a system where multiple devices, computers, phones, servers, etc., are connected to share information, resources, and communicate. Now, let's talk about why networking is important. The internet exists because of networking. Every website, email, and social media platform relies on networks. Businesses use networks to connect offices, cloud services, and employees. Cybersecurity and ethical hacking. Understanding networks is crucial for cybersecurity professionals. Cloud computing and Web3. Cloud platforms, AWS, Azure, and blockchain technology rely on distributed networks. Quick question. Can you imagine a world without the internet? Different networks exist for different purposes. Here are the most common types. Local area network, LAN. This is a small scale network. A LAN is a private network used in homes, schools, or offices. Devices in a LAN share files, printers, and internet access. An example of a LAN would be your home Wi-Fi network. Wide area network, WAN, is a large-scale network. A WAN connects multiple LANs over a large area. The internet is the biggest WAN. And lastly, let's talk about wireless networks like Wi-Fi and mobile networks. Wi-Fi allows devices to connect without physical cables. 4G and 5G mobile networks provide internet access anywhere. An example of wireless networks would be using mobile data to browse on your phone. So let's jump over to how computers communicate in a network. And they need these things: IP addresses, DNS, and protocols. Let's get into it. Every device on a network has a unique IP address, like a home address. Now, there's IP version 4's IPv4 addresses, and they look like this: 192.168.1.1. And then we have IPv version 6, IPv6. And this example is something in this. It's not only in letters, but also numbers. So that's hexadecimal. And you got 2001 with this colon, DB8, FF00. And as you can see, there's more numbers. Local networks use private IPs, while the internet assigns public IPs. DNS, the internet's phone book. Websites have domain names like google.com, but computers use IP addresses. The domain name system, DNS, converts names into IP addresses. An example here would be when you type facebook.com, your computer asks DNS what IP to use. Networking protocols, the rules of communication. Computers follow strict rules called protocols to send and receive data. Here are some most common protocols that you will see in the field. HTTP and HTTPS is how websites load in your browser. TCP/IP, these rules ensure data is sent and received correctly. FTP transfers files between computers. SMTP are IMAP, this handles email services. VPN, VPN, this encrypts your internet traffic for privacy. Quick question. Have you ever seen this before a website URL? Well, that's part of networking security. Now, in the tech world, networking is the backbone of IT, and understanding how devices communicate is essential. This assignment here will introduce you to real world networking using Cisco Packet Tracer, which is an industry standard tool for networking simulations. Even if you're not sure if networking is for you, this hands on activity will give you a taste of the work that's involved in IT and cybersecurity roles. Now, to just give an overview of this homework assignment, you will build a basic network with 2 PCs, a switch, a router inside of the Cisco Packet Tracer software. So your task will include things like connecting the devices with the right cables, assigning IP addresses to PCs and the router, and testing the network by using the ping command, basically to verify connectivity. This is your first step into practical networking, basically understanding how devices communicate in a real world environment. Now, don't worry, I have provided a detailed step-by-step guide to help you complete this. This knowledge is the foundation of careers in networking, cybersecurity, cloud computing, and DevOps. Once you've completed your assignment, take a screenshot of your network setup and your successful ping test. Submit your screenshot via Discord. If you get stuck, post your questions in the Discord group and we'll troubleshoot together. This hands-on activity will help you decide if networking is something you want to explore further. The best way to learn tech is by doing, so dive in, explore, and ask questions. Let's go ahead and do the hands-on activity. So first thing I did was I literally just went into the web browser and put in search for Packet Tracer download. Okay, that's pretty good. What is Cisco Packet Tracer? Make sure that you are downloading from Cisco Academy. That's how you know that this is the real software. So you can just start learning. Get started with Cisco Packet Tracer is right here. You're going to click onto that and you're going to get started. Self-paced. They want me to log in. Resume course. Resume course. And it will say download Packet Tracer and it'll give you the link. Let's go ahead, click on that link. Learning is the best way. Make sure step 1, download the version that you require. Okay, I'm on a Windows, so I'm going to click Windows and it is going to download. You can accept the terms. Just, I just let it download in its default. Create a desktop, sure. I just let it install with its default settings. Usually don't change much. But if you want to change where it gets installed on your computer, you definitely can. Once it has completed the setup, you can launch Cisco Packet Tracer, make sure that's there, and finish. Would you like to run multi-user? No, I don't really care. It'll probably look something like this, but you can sign in. And I use my single site. Ew, no, brother. Skills for all. No, brother. Close the tab. Okay, there we go. So once you sign in, you'll come to Cisco Packet Tracer and it looks as such. Okay. We have our devices down here and some options. I think you should really just play around with Cisco Packet Tracer and just figure out what some buttons do, what you can and cannot do type ordeal. Because for the new eyes, it will be a lot. but I do want you to pay attention down here on the bottom left, and you'll see some devices. So if you hover over it, you'll get the names, well, the sections, the categories. So you have networking devices. Clearly, those are routers. We have in our networking devices down here, we have some switches and hubs, wireless devices, even a WAN. Our end devices right here, you see PC, laptop, server. You can even scroll over to see if there's more. Home, got some items, smart city, and whatever. And this little thunderbolt is connections. These are our console connections, our cable straight through fiber, phone, etc. All right. So let's get into it with the homework. So our objective here is to set up this basic network. So we're going to make sure we have 2 PCs, 1 switch, and 1 router. So let's go over here to networking devices. Let's click our router. A router, these are all different, obviously, models from Cisco. And if, again, from our hardware last week, we learned about different makes and models. So this is different models and under the Cisco make, and you can take a look at these different models. What's the 2911, 2901, the 1941, and the 4331? No, whatever's good for you, you can choose. Okay, so 1 router. So we're going to drag and drop the following devices into the workspace. So we have 1 router, 1 switch, and 2 PCs. So let's get our router 2811. Let's get a 2811 right here. All right. And then we have 1 switch. So let's go down, click on switch category, and the 2960 right here, a switch. Let's put the switch right here. Let's just say. Then we need 2 PCs. So let's go to end devices. We have a PC 1 and a PC 2. All right. Um, let's just make that a little bigger for you. All right. So we got router, switch, PC, PC. Now that we have that together, we have to connect these devices together using cables. All right. So you're a newbie, so you can definitely choose the thunder right here, the lightning. It says automatically choose connection type, right? And what it'll do is you click on that, you click on the switch, you bring it over to the PC, and it'll automatically choose for you. So you can automatically choose, but for this, we're going to use copper straight through cables right here. And you're going to click fast Ethernet, fast Ethernet. All right. Again, you can automatically do it as well. All right. All right, so now that we have that, we now have to assign these IP addresses. I've already given you the IP address scheme. We just have to plug and play. So to plug and play, we're going to go to the first PC, PC 0, as you can see here. Let me make it a little big for you. All right, and then we're going to click on desktop, this desktop. Now under this desktop, we're going to go to IP configuration. And in IP configuration, we can literally add in the IP address. So what we're going to do is add the IP address. So 192.168.1.2. And if you click out of it, it'll automatically give you the subnet mask based on the IP address. I don't want to get too technical, but if you are going down the networking path, then yes, you will have to understand about IP address classes and subnet masks. But for now, just know that if you click out of it, it'll give you the defaulted subnet mask, and we can check our resources. I gave you the same subnet mask. Then what we must do is go down to default gateway, and we must add an IP address for the default gateway. And we're going to add 192.168.1.1. This is the router's IP address, okay? So the PC has the address of the router, has its own address and the address of where the router is at, okay? All right, now we did that. We gotta do the same thing to PC1. Let's go to PC1. Let's go to desktop, IP configuration. Now, We're going to add an IPv4 address, and it's not going to be the same exact address. It's going to be different. So it's going to be 192.168.1.3 instead of .1.2. Subnet mask, as you can see, it already given it has already given the default, which is great, but we must add the default gateway. So the default gateway is the router's IP, so that will be the same. 192.168.1.1. Okay? You could just exit right out of that. Now our PC is configured, our PC1 is configured, and our PC2 is configured. As you can see, we have some green triangles. Now our router switch configuration, that's not really together, it's red. So let's click on our router. Okay, let me click this over here. And in our router, we must go to the CLI right here, command line interface. All right. Now, when you first open up a router, you will have to go through some initiation phase to initialize this configuration. So it says, would you like to enter that configuration dialog? You can if you like, so you can understand some things, but I'm going to say no for this example purposes, for time purposes here. So we're in the router, okay? And what we must do is we must put enable, okay? But I put EN for short when I'm at work to enable now configuration mode. And then we're going to enable user mode. And now I'm going to go to config T. It's configure terminal is the real thing, but config T is shorthand. So that just means I'm now in the configuration terminal to start configuring things. Okay. I gave you all of these commands. You can literally copy and paste these commands. Okay. Now let's look at the interface. We really don't know which interface is which. So let me come here. Let's click out. We're going to come here and take a look. So we got FA 0/0 and okay. So click back in here. So we're going to go to interface INT FA 0/0. Okay, that's interface fast Ethernet 0/0 as we just saw. All right, so now we are in that on that interface, on that configuration line. So now we can configure on the interface specifically. And what do we want to do? The same thing we did with the PC, add some IP addresses. So let's do IP address, slow down, IP address, and we're going to do 192, and we're giving it the IP. This is the default gateway. This is the router's IP address. We're going to give it its IP. We're assigning it. And what do we use? What do we say to the PC? 192.168.1.1. You must push space and add a subnet mask, which is the same thing, 255.255.0. Okay. And then enter. So we assigned it the IP address, we assigned it the subnet mask. Now to wake it up, because you can see it's still red here on our side. So to wake up this interface, we have to do no shut or no shutdown, but shorthand, no shut. I'm showing you shorthand to show you because you're going to do these things over and over again if you decide to go into the network path. And these are the shorthands you're going to use. Okay. But obviously you're new to it, so you need to understand the full command. So no shutdown, but no shut. And then no shut, we get a system log. This system log, this message, the system message says interface fast Ethernet 0/0, change state to up. So it's a line protocol number 5. That's a system message. Number 5 is just giving you information, letting you know that the line protocol on interface FA 0/0 has changed state to up. All right. And you can see over here, it's green. All right. Now, what you also can do, press enter, you're still in the configuration. So what you also can do is do exit to get out of the interface. You could do N to get out of configuration mode. And sometimes you can do, oh no, I meant to do right WR. but I accidentally fat fingered and did QR. And now it's trying to look up this misspelled command that I did. So it's going to take a minute. And you just have to let that go, let that kind of time out. And then, so I'm going to show you guys. Just wait. Let's let it time out. Okay, cool. So I accidentally typed the wrong thing here and it took forever just trying to look and translate to figure out what does this mean. It doesn't mean anything. So you can go to conft and in the configuration terminal, you can do no IP dash domain lookup. I believe that's what that is. Um, let's do okay, oh, I didn't have to put the dash. So let's do no IP domain lookup. And anytime I do, let's do it again. Let's do QR. You know, it's just gonna say invalid and be like, you need to try it again. Okay. So what I can do, because I did all these commands and I don't want to lose it, I can literally say write memory. All right. Um, I gotta end and I gotta do right. WR is better. And it says building configuration. Okay, right here, as you can see. So basically it's the same as write memory. Okay. Um, and again, that's just to save all the configs that your hard work, just make sure you save it on the router. So now, as we can see, we have all green. All green means you should be able to communicate. There's no blockers, okay? So let's go to PC0 and let's see if PC0 can talk to PC1, all right? So let's go into the terminal, or we can go into command prompt, sorry. So in our command prompt, we're using the network connectivity test, which is ping command. So we got ping 192.168.1.3. That is PC1's IP address. So let's see, can we ping it? And a ping means, well, like ping pong. So if I hit the ball, it's supposed to come back to me. So if I say, hey, I should get a hey back. That's how ping works. That means that I can communicate with you. This device can communicate with this device. Okay. Or I should say, this IP can communicate with this IP. All right. And that's all we're testing. And as you can see, we have reply from PC1 saying, yep, you're good. Right. We got the bytes, we got the time to live, and we have no packets lost. Can you see 0 loss? That means that it can communicate. So what I want you guys is to do the same exact thing. Follow these same exact steps. Definitely be curious, mess things up. This is just a simulator tool. You're not gonna bring down any type of real life network anything, and you know, test it out. Now at the end of this homework, what this should have taught you is how to set up a basic network, how to configure IP addresses, how to test connectivity with the ping command, and how routers and switches work together. If someone has networking skills, the ability to design network layouts, assign IP addresses, and understand hardware components, they can qualify for a variety of high-paying IT jobs. These skills are valuable in several IT departments, including network and infrastructure team, which manages the network setup, troubleshooting, and optimization, IT support and help desk, which troubleshoots network issues and assists employees with connectivity, cybersecurity team, which secures network communications, prevents attacks, and configures firewalls, cloud and data center operations, which they manage cloud networks, server infrastructure, and virtualization. My department, telecommunications, VoIP and unified communications, which we work with voice, video, and data communication systems. Their responsibilities and salaries. 1, network administrator. They configure and maintain routers, switches, and firewalls. They assign IP addresses, subnets, and VLANs. and they monitor and troubleshoot network performance issues. Their salaries start off at $65K a year. They can go all the way up to $110K a year, just depending on your region. The certifications to get here would be CompTIA Network Plus, possibly the Cisco CCNA, or even the Microsoft certified Azure Network Engineer. 2, Network Engineer. Network engineers design and build enterprise networks like LAN, WAN, even SD-WAN. They configure VPNs, cloud networks, and network security policies. They also work with Cisco, Juniper, and Aruba networking devices. Their salary here is going to start them off at $90K and can range all the way up to $140K a year. Now, certifications to get you started would be the Cisco CCNP, the Azure or AWS Certified Networking Specialty certs, or even Juniper Network Certified Associate. 3, IT Support Specialists, or they called help desk technicians. They troubleshoot network connectivity issues for employees. They set up Wi-Fi, VPN printers, and other network devices. They also work with basic networking and Windows, Linux, OS troubleshooting. The salary here will start you off at $45K a year and can range all the way up to $75K a year. Certifications to get you started would be something like CompTIA A+, or the Google IT Support Professional Certificate. 4, cybersecurity analysts. Cybersecurity analysts secure corporate networks from hacking attempts. They configure firewalls, intrusion detection systems, IDS, and VPNs. They also monitor network traffic for potential security threats. The starting salary here is $80K a year, and it can go all the way up to $130K a year, depending on your region. Some certifications to get you started would be the CompTIA Security Plus, the Certified Ethical Hacker, CEH, or the Cisco Cyber Ops Associate. 5, Cloud Network Engineer. Cloud network engineers manage cloud-based networks in AWS, Azure, or Google Cloud. They configure virtual networks, VPNs, and hybrid cloud connections. They also secure network traffic between cloud and on-premise environments. The salary here is going to start you off at $100K a year and can go up to $150K a year. Certifications to get you started would be AWS Certified Solutions Architect, Associate, Microsoft Azure Network Engineer, Associate, or even the Google Cloud Certified Network Engineer. 6, VoIP Engineer or Telecommunications Engineer. What VoIP engineers do is set up and manage VoIP phone systems and video conferencing tools. They troubleshoot call quality, SIP trunks, and voice gateways. They also work with Cisco Unified Communications, Avaya, and Microsoft Teams calling. The salary here is going to start you off at $75K and can go all the way up to $120K a year. Certifications to get started here would be Cisco CCNA Collaboration, Avaya Certified Expert, ACE, or the Microsoft Teams Voice Engineer Cert, or the 7, Data Center Technician. Data center technicians maintain and configure enterprise network equipment like routers, switches, firewalls. They install and monitor server hardware, racks, and network cables. They also work in large-scale data centers like AWS, Google Cloud, Microsoft, even IBM. Their starting salary here is $60K, and they can go all the way up to $100K a year. Certifications to get here would be the CompTIA Server Plus, Cisco CCNA Data Center, or the AWS certified data center technician. If you're new to IT and networking, here's a roadmap to start a networking career. Step 1. Learn the basic networking concepts like IP addresses, DNS, DHCP, subnetting, etc. Step 2. Get an entry-level IT support or networking certification, such as CompTIA Network Plus, CCNA, etc. Step 3. Build a home lab or use network simulators like Cisco Packet Tracer or GNS3. Step 4. Apply to entry-level jobs like IT support, network technician, help desk, etc. Step 5. Specialize in cloud security or VoIP for higher paying roles. So what's the best networking career for you? If you want to start quickly, choose IT support, network technician, or even data center tech. If you're interested in higher paying roles, go through the path of network engineer, cloud network engineer, or even cybersecurity analyst. If you love security and hacking, try cybersecurity specialist roles or ethical hacker roles. Passionate about cloud tech, join cloud network engineers or AWS Azure networking specialist roles. Which networking career are you most interested in? Just to bring this lesson full circle, networking connects all modern technology. LANs, WANs, and wireless networks keep us online. Computers use IP addresses, DNS, and protocols to communicate. And then we did hands-on activity, which we set up our own home network, office network, and check connectivity.